Assalamualaikum. My name is Nur Nadira binti Azhar. My matrix number is CF230182. Today, I will go on to present about fieldwork activities we carry out as part of our geotechnical investigation project. Throughout this project, we conduct several important in situ tests such as field vein shear test, Macintosh probe test, and sand cone test. These tests were done to help us better understand the soil condition at our site and to gain hands-on experience with real field equipment and procedures. Each test served a different purpose and gave us valuable data related to soil strength, density, and bearing capacity. Now, let me walk you through each of the tests one by one, including the purpose, procedures, and the findings we observed at Recess UTHM site.
So, for the first test, we conducted the field vein shear test to determine the unjoined shear strength of soft, cohesive soil directly at the site. This test is important for evaluating the stability of shallow foundation, slopes, and embankment. The results showed that the reclaimed area had higher shear strength due to compaction, while the waterlogged area was much softer. This gives us insight into soil behavior in different. So, the second test is the sand cone test. Sand cone test was used to measure the in situ density of compacted soil. This method is essential to ensure that compaction meets engineering standard. By filling a hole with sand and comparing volume, we calculate both bulk and dry densities. The result confirmed that the soil was fairly well compacted and suitable for construction. And the last test is the Macintosh probe test. Macintosh probe test help us estimate the strength and bearing capacity of the soil layers. We drop a cone tip rod into the ground and record the number of hammer blows per 300 mm. This high number of blows indicate that the soil is medium stiff and has moderate resistance, which may be suitable for shallow foundation depending on the structure plan. The vein shear test, the equipment that we use is vein blade that is inserted into the soil and rotated to cut through it. It measures the resistance of the soil to shearing. The second equipment is torque gauge. This device measures the torque or turning force needed to rotate the vein. It gives us the value needed to calculate the soil shear strength. So the other equipment is extension rod. It's used to extend the length of the vein blade so it can reach deeper soil layers. Other equipment is measuring tape used to measure the depth of the test point before and after inserting the vein. And for the step during the test, we first insert the vein into the soil using the rod and extension, then connect the torque gauge to the head assembly, and we rotate slowly and record the maximum torque which we use to find the shear strength. So for the equipment for the second test is for the sand cone test. The equipment includes metal tray with a center hole placed on the ground surface and used to guide where the hole is dug. Second, cylindrical container, sand jar, filled with clean, dry sand is stored and release the sand during the test. Second is pouring cone attached to the sand container. This allows sand to flow smoothly into the test hole and fill the exact volume. So for the step to do this test, first we place the tray and dig a hole. We collect and weed the removed soil. Then we place the sand container with the cone over the hole, open the valve and allow the sand to fill it. The volume of sand used gives us the volume of the hole, and from that we can calculate the soil density. So for the next test, that is Macintosh probe. The equipment that we use is a marker or liquid paper to mark the road. Second is hammer. A standard hammer, typically 4.5 kg, is rubbed repeatedly from a fixed height to drive the road into the soil. Third is rod section and jointer. This function is the rods can be extended using jointers as we go deeper into the soil. Next is measuring depth. It's used to measure the depth of penetration for each interval, usually every 300 mm. And the last equipment is rod exactor. That is, after completing the test, this tool is used to pull the rod back out from the ground. So for the procedure of the test, we assemble the cone tip rod with a hammer and drive into the ground. We count the number of blows required to penetrate each 300 mm layer. This gives us an idea of the soil stiffness or softness at each depth.
Now, I will explain about the analysis data for Macintosh prop test. From our result, we can say the soil is in the medium stiff soil category because all the blow counts are above 120. The high blow count shows that the soil has high resistance and may suitable for shallow foundation. Depends on what the type of the structure. Now, I will explain about the analysis data for field vein shear test. From the data collected, we compare the data one by one. We can conclude that the first test location is likely stiff or compacted soil, which makes sense because we were informed that this area was a man-made field or reclaimed ground. The second test location, on the other hand, shows soft soil condition, most likely due to long-standing surface water or ponding, which has caused the ground to become weak and saturated over time. To improve the accuracy and reliability of the data, it is better to take readings at a regular depth interval such as every 0.5 meters. Now, I will explain about the analysis data for sand cone test. When compared to common values in textbooks or industry standards, a dry density of 1.45 gram per centimeter cube is acceptable for many construction works. It suggests that the soil compaction is good and likely meets typical requirements for road beds, backfill, and embankment layers. Usually, if the dry density reached 90 to 95% of the maximum dry density from a Proctor test, the compaction is considered sufficient.
In conclusion, this fieldwork project has given us a better understanding of how different soil tests are conducted on site and why they are crucial in civil engineering. The field vein shear test help us measure the underlying shear strength of soft clay soil in their natural condition. But for the sand cone test, allow us to calculate the in-situ density of compacted soil, which is essential for ensuring proper compaction on construction site. And we also get that Macintosh prop test give us insight into the soil bearing capacity through a simple, effective method. So, in conclusion, each test provides valuable data and practical experience that will be useful in future real-world engineering work.